Hi, let's solve today's daily challenge, that is squares of a sorted array. So in this question we are given an array nums which is sorted in non-decreasing order, which is nothing but increasing order, and we need to return an array of the squares of each number sorted in non-decreasing order. Okay, so look at the first test case. So this is a array, right, which is given to us in sorted in non-decreasing order, right? So -4, -1, 0, 3 and 10, and what we have to do is square these numbers, correct, and we have to return what, a sorted array in non-decreasing order, right? So this is what we have to basically do, right? So quite easy, right? So what all you have to do is square this number, square this number, square the number, right? So you will get something like this. Now this array also, right, resultant array, you can see that it's not sorted in increasing order, so you have to sort it in increasing order. So you will get 0, 1, 9, 16 and 100. So this is what you have to return. Now if you try to create an array like this, and you can simply sort it, right? So the time complexity you're going to take is n log n plus n for one traversal in this array, right? So n log n for sorting it after you create this array, after traversing this array, correct? So the catch here is that we don't have to actually utilize n log n time complexity, right? We can do it in a single pass. How? See, you have to observe this very thing that is written in the question, right? That is, the integer array given to you is already sorted in non-decreasing order. Now if you observe that this particular test case, right, see, whenever you square, the number becomes positive, correct? So -4 into -4 is what it is, 16, right? So it's a positive number, not negative number, right? So squares are always positive. So that's the first thing. Now what will happen because of that is, let's say this is right now might be minus, right? Because obviously it's ordered in increasing order, but its square will definitely not be negative. And if its square is not negative, so look at this particular value, it's 16, right? And it's 1. And look at the positive values. See, this is 100 and this is what, 9. So we already know that this array is what, sorted, correct? So is it right for me to say, if I take a left pointer here and a right pointer here, what I'll do is, instead of checking, right, instead of checking the squares, you can check, is this particular value, right, abs of this, right, and this, are they like, is this value greater than this value, right? Because it can happen, because if you have a negative number, suppose you were having -4, 0, 1, 2 and 3. So here you can say this is 16, this is 9, right? So if you just have a pointer here and a pointer here, so you can compare these values before you put a value in the array. So what you'll do is, you'll compare these two values. Now the reason, see, and we will start filling up our array like this, right, from the back side. Now the reason we will start filling our array from the backside is that, see, we are comparing these two values, right? If I check the smaller one, it's a smaller one can fit in any of these, right? We don't know where it will fit, but we want to see what we want to do is, this is 16, right? This is greater, and this was -4. So you have to check for the greater value. If the negative value, if the negative value is greater than the positive value, then you have to put it here, correct? So take 16 and inside the array, then move the pointer which was the greater number. So the greater number was -4, so move the pointer here. You are on left side and right side. So right side you can already see is still greater, so you will insert 9 here. Then if you'll insert 9, you'll move your pointer here. So this is 2, this is 1, again this is greater, so move the pointer here. Then 1 and 1, so you can take either of these, right? So you'll take one, let's say I take this one, and then I'll compare this, and then I'll take this one, and then for 0. So here you can see that we have leveraged the fact that the array was already sorted, right, to decrease the time complexity of n log n. And how are we doing it? We are doing it by using two pointers, left and right. And what we are doing is, we are comparing if the negative number we have inside of the array, is it greater than, if it's a square, will be greater than the number that we have here. correct? So that is all we are doing, and this way our time complexity is becoming only big of n. So there's only one pass, and space complexity, there is no extra space that we're going to use. It's just we have to create this array and return it also, right? So for that you might consider time complexity, but it's not extra space, right? That's where you're calculating the answer. The extra space in this case is also big O of 1. So time complexity big O of n, space complexity big O of 1. So I hope you understood it. Let us quickly see the code. So although the code is very short and pretty easy. So first take the size of the array, then take two pointers, left, right. So left will be initialized to 0 and right will be initialized to n minus 1th index. And then you are taking, now you'll start filling up your array, resultant array, okay, from the last index. And the reason being that you are checking if a negative number, right, its square would become more than the square of the last number or the later numbers in the array, or the positive numbers, greater positive numbers in the array, correct? So that's what you have to check. So that is the reason you have to start filling from the backside. Then you are taking this vector resultant, and then you are simply iterating. So you are checking left less than equal to right, and here you are checking if nums of left is greater than sorry, abs, right? So you're checking positive value, you're considering only positive value. So see, here the positive value of 4 was greater than 3, right? So we'll consider 4 and move forward. So in rest of I will include this left value and we'll do left plus plus. Otherwise we'll include the right value and we'll do right minus minus. And in either of the scenario we will be filling up something, and then we'll do I minus minus simply, and this way our resultant array will be created and we can simply return it. So this is basically how you have to solve it, and let's quickly run it. So it's accepted. So this is basically the logic or of the problem.